Good evening to all of you. Today I'll be presenting a topic in maths, and that is going to be arithmetic progressions. Now, how will you define arithmetic progressions? Well, a way to put it out is that it is a sequence of numbers in which the difference between consecutive numbers is constant. What do I mean? Now, if you didn't understand that, I'll take an example. Let me take an example of an arithmetic progression. An excellent example can be even numbers. Now, even numbers include numbers such as 2, 4, 6, 8. These are a sequence of numbers. Now the difference between the consecutive number. So, of course, they're consecutive and they have a constant difference. Now, what do we mean by that? When we refer to difference, normally the difference refers to subtraction in mathematics, unless you're talking about differentiation, which is completely different. But let's get back on topic. In this reference, we're talking about difference. So difference means subtraction. So both of them have a common difference, meaning there is a common value. There is a common value that separates one from another. If you add that common value to each, you get each of the consecutive terms respectively. 2, 4, 6, 8. So 4 minus 2 is equal to 2. 6 minus 4 is also equal to 2. 8 minus 6 is also equal to 2. Here, the constant difference is 2. So, first factor is satisfied. It's a sequence of numbers. There are also consecutive numbers in the sequence. And they have a common difference of 2. So, that is... So, now I'm pretty sure you might have understood what arithmetic progressions are. Now, where are we going to use stuff like this? Now, when I explain you the examples, think carefully about what arithmetic progressions are. It's a series of numbers with a common difference. And when I read through each of them, think carefully. You can pause the video and think carefully as to where each of them are. If you don't, then if you can't guess, then you can play it anyway. A real world example is the first real world example, calendar dates. So dates on a calendar, they can of course have equal difference. Like you can say a set of days between 2 months, like between, no, you can't say that. But calendar days can potentially contain a constant difference. Savings plans, like if you want to save a specific amount of money, you can continuously increase the amount of money you're saving. You can put more money into your area of deposition, the place where you're saving into. So yeah, you can use it for savings plans and concert rows. Now, if you go to a concert, there will be multiple rows of seating. So each of those rows could also be a set of series, because each of them has a separate number assigned to them at times. And those separate numbers could be in a constant difference. Same for theater seats. Page numbers can also have the same thing. Workout repetitions. Basically, you can do the same thing as saving plans. Increase more and more workout repetitions over time. Now, here are some industrial scale uses. Like what industries use them, not on an individual level, but stuff like construction architecture, like the duration of construction, the amount of materials required to construct, etc., etc. Finance and banking, it could be based on how certain investments or certain loans get paid back, or investments increase in value. Retail and e-commerce, you can say it could either be based on price increase or price decrease. Like some people, maybe they could have some specific privilege. Some customers may have a specific privilege. So as a loyalty, a loyalty thing, like a loyalty reward. So based on that, they will slowly give you more and more discounts. And there's also transportation, which is based on basic timings, and they're obviously used in data analytics. Now let us look at some key formulae. Now, here are some key formulae. Of course, now it looks like a bunch of alphabet. So let's bring back a random example. How about let's take something like, I know, we can take 7. No, this. We can take 7, 14, I meant to say, hold up. Sorry. Just hold on a second. I might be taking a bit of your time, but it won't be too long. So 64, 71, 78, 85. Now first, let's find the value. Let's find the difference. To do that, we'll first actually we have to find whether it's an arithmetic progression to begin with or not, and that will be through regular trial and error. 71 minus 64, you get 7. 78 minus 71 is 7. 85 minus 78. Yeah, that's also 7. So in all these cases, the common difference here is obviously 7. So we can point the common difference being 7. Now 7 is equal to d. That is the variable that is there in all these formulas. Now you know what we consider this to be? This is the value of a. Now that we have the value of d and a, we can figure out what is the actual formula for, well, how arithmetic, like the prototype of arithmetic progression. Like you have a human. No, let's not do that. You take a car, and at the center you have a chassis. Similarly, here you have this one. You have arithmetic progression, and you have what is inside a, which is the first term, a plus 2d, a plus 3d, and onward till a plus nd, n being the number of terms. Now, no, actually it's a plus, and it just goes on, but the last term of a specific arithmetic progression is basically a plus n minus 1 into d. Here a is obviously the first term, d is the difference, and n is basically the number of terms that are present in the arithmetic progression. So here of course n is 85. You can consider n to be equal to 4, a is equal to 64, and d is equal to 7. So accordingly you can accordingly you can find the values, you can substitute and find out that the ending you'll get is 85. And now we have move on to another formula. Now d, of course, d, this is how you find d. If you subtract the a2 minus a1, you can also do the same thing by basically doing taking any number from the arithmetic progression, and inside the arithmetic progression subtract the preceding number from it. Here it's a2 and a1. a2 minus a1 is going to be 7. That's how you find d. Now A of n. Okay, A of n is basically L. And now let's find now what is S of n. See, if you want to find the value of all four of these numbers, you can do that just using this formula. S of n, S being short for sum of the n number of terms in this arithmetic progression, n number. And here it's here we can basically have 6 4 and 1's 85. Instead we have, so first of all take the number is equal to 4 by 2 into 2 into 64 plus 4 minus 1 into 7. Now we get 2 into 128 plus 21, which basically brings us to 256 plus 42. Now let's briefly solve this. You get 298. So if you add, of course, my calculation might be a little wrong here, but if you add all four of these numbers, you'll get 298. And if the result if I'm wrong, that means my calculation was wrong, because all of these formulas are correct. Now let us do one thing and let us take a question. Go. Alright, so during an F1 training session, Shashwat records the lap time of a driver. The driver improves his consistently reducing his lap time by 2 seconds for each lap. Now if his first lap takes 100 seconds, how long does the fifth lap take? And what is the total time for the first 5 laps? Total time for the first 5 laps. Okay, so I'm pretty sure you'll be confused if I just throw a word problem at you. So let's just pluck the main data out and see what we're giving. During an F1 session, Shashwat records the lap time of a driver. The driver improves his speed continuously, reducing his lap time by 2 seconds each lap. That means for each lap, okay, do one thing. Like this. So of course, in each lap, we're given that his lap time reduces by 2 seconds. Maybe we can consider that as D. First lap is 100 seconds. And how long we need to find the time taking for the 5th lap. Total time for of first 5 laps is equal to a value that we find. So we're given that each lap takes 2 seconds. I mean, it reduces by 2 seconds. When the driver goes around the track, every lap that he takes, it reduces by 2 seconds. The first lap is 100 seconds. But now what we do with these data? We can actually consider this as T, the common difference. Because for each lap, it's reducing by 2 seconds. And the first lap, since it's the first one, it might actually be the first number, which is equal to A. So the 5th lap is so now we have to find the value of the 5th lap. So to find the value of the 5th lap, we take this. So the value will be, let's first plot it out. It's going to be A plus D, A plus 2D, A plus 3D. This is the 4th one. A plus 4D. And this is the 5th one. Now we're clearly given A. A being equal to 100 seconds. A is 100 and D is minus 2. 100 plus minus 2 into 4. 100, which gives us 100 minus 8 being equal to 92 seconds for the 5th lap. So now this, we found out the value of this is 92. Now what is the total time taken of the first 5 laps? For this we have to bring out the SN formula. SN is equal to n by 2 into 2a plus n minus 1 into t. Yeah. So yeah, we have the formula. First let's the n, obviously here n is equal to 5. 5 by 2 into 2 into 100 plus 5 minus 1 into D is minus 2. Perfect. Now we have 5 by 2 into 200 plus 2, okay, that will be minus 3. Take that and here put a minus 3. 200 into minus 3. So, and that gives us the ending result of, not the ending result yet, but 5 by 2 into 197. So 197 by 197 into 5 by 2. Okay. Hold up, I'll just do calculations again. Ah, yes. So that brings us to 985 by 2, which is going to be equal to, pull it out, to 985. 2 4s are 8. So 2 9s are 18. Now 2 4s, and then you have 0.5. So the final answer is 494.5 seconds. Well, that's actually wrong. Whew. So the result here is wrong. Let us quickly solve this again one more time. So formula is S of n is equal to n into n by 2 into 2a plus n minus 1 into d. 2 into 100. Okay, let's take it back. All the values are correct. Now let's just quickly solve it again. 5 by, let's make some new space. We'll have to rub out a bit of the question. Hopefully you can, if you forget the question, you can just go back and take a screenshot real quick. But yeah, let's go. So here we have 5 by 2 into 2, okay, 5 by 2 into 200 plus 4 into minus 2. It's not good. Okay, actually, hold up. We have a common factor 2 here. How come we didn't notice? So we can actually pull 2 out, and then actually that will bring us to 5 into 100 plus 2 into, okay, 4 into minus 2 is minus 8 still, that is still kind of works. So that is 5 into 96. Actually, or I fear that I've gone wrong again. But let's see. Okay, this time we actually got the result correct. So, yes, that's all we have for arithmetic progressions. Thank you for listening. I hope you learned something new.